we've all heard a lot about role-based policy control, and we were talking about using VXLAN information to carry roles across the SDWAN fabric from one switch fabric to the other, campus to campus. Role-based policy control is something that we are now in the process of adding to enterprise appliances. Last year we introduced visibility, so integration with ClearPass, so that as flows traverse the enterprise appliances, you could see role information, user information for every single flow. Now we're taking that one step further, and we're enabling the administrator to use those roles for policy enforcement. So those, and I'm marketing's probably kicking me for not saying security immediately, but that's, I think, primarily the use case for this ultimately. But the enterprise appliance will be able to use role information to define any type of policy. So whether that's a firewall, zone-based firewall security policy, whether that's in terms of steering traffic, like whether or not we want to send some user who has been identified as guest to Zscaler, or break out their traffic directly to the internet, or a selection of which business intent overlay that particular user should have their traffic transported through, which determines the the level of QoE they're going to get, how much packet loss correction we're going to do, how we're going to balance that traffic across links if we're sending it to another site, QoS, all of those things. So there are 3 different places that the appliance can, or 3 different sources from which the appliance will be able to determine what the role is. And so one of those is just ClearPass integration, right? So ClearPass, ClearPass sends us telemetry and says for this particular IP address with these identifiers, this is the role, this is the user information, right? And that's necessary in some environments. In other environments, maybe where there isn't a VXLAN enabled switch fabric on the LAN, which that's going to be a lot of locations. Your typical retail location, for example, or maybe a small clinic and a hospital system. In that case, we are doing a combination of radius snooping to start, and eventually radius proxying. So we just much like we do today with to build a DNS cache for first packet-based recognition of applications, which is important for security policies. Today we snoop DNS requests. We snoop the SNI header and SSL negotiations to build that cache. So we're just building onto that logic and adding the ability to parse the role information out of the radius requests going through the appliance. So snooping to start, and proxying eventually, simply because of the advent of RadSec and cloud-based NAC. We've spoken to customers, and we haven't seen extensive deployments of RadSec yet, so that's why we've started with snooping instead, assuming that radius traffic will be unencrypted, across a private network. But that proxying is on our mind as well. And third option, which you guys heard about earlier with NetConductor, is recognizing the role information from the GPID tag sent to us from a VXLAN enabled switch. And it's not that the user will have to choose between these. We will just do this automatically. So we can, these are the potential sources of information and pipeline from which the enterprise appliance can derive what the role is. So which fits any number of use cases. So you don't have to have VXLAN switch stack, for example, in order for this to work, right? I mean, this could work at a site that just has a standard layer 2 switch.
Because it's going to the end device. If that's an AP or a laptop with BIA or...
Yeah, exactly. As long as the enterprise appliance is in the path to the Radius server, which typically you'd host at a data center, then we'll be able to snoop that Radius traffic and derive the role. A couple of visuals to give you an idea of how this role information can be used. So we're getting away from VLAN-based definitions or subnet-based definitions of to segment traffic, and we're just simply creating a policy that says guests go into a lower priority class in the shaper, employees higher priority. Do we want to do IDS IPS inspection on guests or employees? We can enable it on one or the other. What do we want to do with these roles? Internet traffic. Whereas today, today for network administrators, it's a lot more complex. And with role-based matching, it allows you to create a much simpler policy for your entire organization about what roles and what people are supposed to be doing, as opposed to what VLANs are supposed to be doing. It's just one of the use cases and how it can improve security and the user's experience. Okay. Other one, roles across the fabric. Exactly what we talked about, right? With carrying, potentially deriving that information from VXLAN headers, but you could that's actually not even 100% necessary, right? The enterprise fabric can carry that role information irrespective of what source it's received it from, and make decisions end to end about the QoE, quality of experience treatment, that's going to give for a particular role. So it's no longer that you necessarily have to match just, I don't know, VoIP, very generic example here, VoIP traffic to, the real-time overlay, which has more aggressive loss and jitter correction. Now you can match specific roles to that overlay, or maintain an end-to-end zone-based firewall policy from site to site based upon roles.
The middle EdgeConnect fabric, what's it made of? I'm guessing a bunch of different WAN links, which are going over the internet.
Yeah.
Why don't you just peel off the guest internet on the first EdgeConnect rather than transversing the internet multiple times?
So the fabric could also include MPLS and LTE and satellite, and it includes also our tunnel bonding and error correction and all that other magic that we do.
But it seems like you would be sending a lot of traffic over something that might be more expensive than if you just dropped it.
So
Local.
Yeah, so that gets configured in the policies. If I want my all of my internet-bound traffic to be broken out locally over the internet and just use the internet and not use MPLS, we can specify that, and we can send it to Zscaler first, just using the internet, and only use the MPLS for backup. But for my accounting application I still host in my data center, I want that to go over MPLS because I have PCI compliance.
That was more of a simplified marketing. In the real world, that middle cloud would be a little more complex.
Correct.
Yeah.
Correct.
Yeah, that's right.
We're actually starting to see, just a comment on the Zscaler stuff or the SASE solutions in general.
Yeah.
We're starting to see more interest in some architectures where they're eliminating .1x in the environment altogether, and they're using a SASE-based solution, internal and external, to get away from some of the client challenges that are associated with 802.1x.
Yeah.
And let people just take this, go home with it, go to the coffee shop, whatever,
Yeah.
right? And it seems like this would just take that too. It wouldn't care really what's happening, right? As long as
No.
you can see the traffic and the headers and stuff if it's encrypted or whatever, but.
Yeah, yeah, exactly. And that's the advantage also of, I mean, from a behind the scenes perspective, not building a proxy is there's less for the customer to configure, right? We just snoop what we see, like you said, and are able to apply policy based upon it. There's, doesn't require days worth of work to figure it out. So you asked about what the SD-WAN Fabric was. I thought maybe we should take a moment to show you. So the Silver Peak technology, so EdgeConnect Enterprise, takes a bit of a unique approach to location-to-location SD-WAN. We use some terminology. So we talk about transports, the underlying links, which you can see represented here in, INET A, INET B, INET C, and so on. We build underlay tunnels over those different transports, so MPLS, broadband internet, fiber internet, Starlink, whatever it might be. And then in our code, we take those tunnels and we bond them into virtual networks. Like, back in the T1 days, when you bond T1s, you need to have a multi-link or a multi-link.
You're not old enough to know that.
David was telling me about T1s and multi-links backstage earlier. So it's the same concept though, very much so, right? The multi-link sort of becomes a virtual network. A pseudo wire is a virtual network. A VXLAN is a virtual network, right? And it's for the applications. Their experience is it's abstracted from whatever's going on underneath. I mean, even for someone who just buys a plain old MPLS service, it's the same thing. There's a gazillion different transports and fiber paths across a service provider's network, but that, they just have one RD set up for that particular customer, and it's a layer 3 domain for them. The business intent overlays take that a step further and create separate virtual networks on, a per group of applications basis. So you see, guest, real time, best effort, recreational in here. This, could be set up in any way that's appropriate for the business. And then based upon the policies that you define and the applications or now roles that you match into that overlay, the gateways will automatically use those underlay tunnels to meet the service level objectives or the link bonding policies that you've specified for a given group of applications or a given group of users. So for one group, in this example, we're talking about real-time traffic. So it could be everything from, SCCP and SIP signaling and RTP to Zoom and everything that goes along with that, or WebEx matched into this overlay. We've applied a high availability link bonding strategy to it, which comes with several different characteristics. It comes with a more aggressive method of packet loss correction, a more aggressive reordering and shifting of traffic from one link to the other. And whereas for your, let's say, your default traffic, the rest of your business traffic, maybe you don't need as aggressive of a packet loss correction method because your standard web browsing HTTPS traffic isn't as sensitive as a high resolution video conference, and so that error correction is being done on just the real-time traffic. So maybe this is all the traffic traversing between sites. Real time is just this much. Error correction, additional effect packets are just acting on this traffic, but it's not applying that same correction or the same level of correction to everything else because you've decided as the network administrator that it's not needed in that case. So virtual networks, all of the different characteristics that you might have to configure manually in a CLI for QoS, for PBR to steer traffic across different paths. I mean, in some solutions enabling forward error correction manually, decisions, within routing protocols about, or with BFD, for example, about when to fail over between different paths. All of these settings that you have to configure, oftentimes across thousands of devices, are abstracted to this screen.
Is that, from the admin's point of view, is that I just pick a simple drop down? Because obviously all of the CLI commands you're talking about have to take place at some point.
No, the user.
Doing them. That's the SD part.
So what we're doing is leveraging APIs that we've built. So
Right.
all of the enterprise appliances have configuration APIs, if you will. So once a user hits save and applies this overlay policy to a particular appliance or group of appliances, the orchestrator uses the appliance APIs to push that configuration out.
My question is more about the admin interface. How do they choose which portion of that? It's going to apply some API call to make it actually happen.
Yeah.
But how do they interface and say, do I want that, or is the system itself saying, we think real time needs to have that error correction on it, and HTTPS doesn't? So who's making that decision?
Every enterprise gateway out there gets, the administrator assigns a label to each of the WAN interfaces on that gateway. So in the case of my gateway at my house in Los Angeles, I have two wireline links. One of them's a small fiber internet provider, lucky enough to have in my neighborhood. Second one I think it's cable internet service, and third one is just an LTE connection that I have. And I've applied a label to each of these WAN interfaces so that when, as an administrator, I define these global policies, which may use the various interface labels out there differently, depending upon the needs of that group of applications. And when I go out and I decide that I want to apply, or I could remove those policies, but apply those policies to a particular appliance or to a group of appliances, based upon the labels that it sees on the appliances, it will say, okay, I need to build these tunnels because I have INET A over here and I have INET A over here. Or because I have INET A at my hub and INET A and INET B and INET C here, and someone's checked the cross-connect box. There is no CLI configuration that's necessary to make that work. It's just those three screens. It's the deployment screen for the appliance where you apply the labels. It's the business intent overlay screen that we saw, where you decide for that group of applications how you want traffic to be steered, corrected, et cetera. And then this apply overlay screen where you decide which appliances you want to apply those policies to.
So I have a question for you. So the software-defined WAN is meant to enable network slicing. So rather than applying policies down to boxes, I can basically say, hey, I'd like this policy applied for this application or for this use or for this service.
Yeah.
How does that orchestration and that network slicing fit in with this model that you're presenting here? Like, is there another layer that you're delivering on top of this?
Yeah, it's part of the business intent overlay experience. Actually, is that I can say for real-time traffic that I might just pull up a list here, is that I can match either based upon roles now that we're adding, or based upon applications, I can match something like Zoom as soon as this loads. There we go. And I can decide that for Zoom, and maybe a list of real-time applications like Zoom that have common requirements. I mean, Teams, Zoom, WebEx, they're all going to have essentially the same needs from the network. Typically the same needs from a security perspective too, in many contexts. Usually, customers will have a very simple business intent list of business intent overlays, where they are matching particular applications into those overlays. And the software-defined part of it is, the automation that we do, taking care of determining what is Zoom traffic, for example. Having various ways to identify Zoom traffic, either by having a map of their public IP address ranges to Zoom domains, snooping DNS requests, and the SNI header and HTTPS or SSL negotiation to build a cache so that we know. So the user doesn't have to think about defining all of that. They should just say, I want Zoom traffic to be broken out to the internet directly, or I want it to be sent to Zscaler, or it's so important to me, I want to backhaul it to regional cloud hubs first and protect it before I send it out there.
I could have something like all of my Zoom traffic, like if I'm a user, however I connect to the network, my Zoom traffic could go to the public cloud because I'm less concerned about the security of it.
Yeah.
But if that user is doing an application like, I don't know, internal contracts or something like that,
Yes.
engineering specs, that traffic could stay within my internal data center.
Yes.
So that's a kind of thing
Yeah.
we could do, even though, no matter where I connect on the network, that's what this is enabling.
Yeah, precisely, exactly. You'll see two different tabs in here, right? One for what to do with internal traffic, and then what to do for internet-bound traffic if there's a match to this overlay because you've listed that application. So it frees network architects and administrators and engineers from having to manually configure these sorts of policies in a CLI, and instead visually implement their architecture with drag and drop and API-based integrations that we have with Zscaler and Netscope and others. So I think.
And with that goes my quality of service, whether it's encrypted, all of those things, all of those policies can get applied to those different applications that user is
Exactly.
doing,
Yeah.
right across my network.
Exactly. Yeah. No need to do it device by device. You can do
And that's
it.
the real value of this, right? Is doing this. Okay.
Yeah.
So today then also the orchestrator is handling those specific device types we talked about, right? The rest of the Aruba world, switches and controllers and things also have capabilities to detect application types and those types of things, right? Like AppRF and those types of things. So as kind of the worlds continue to come together, we see we should probably be able, it would make sense for all this to wind up fully integrated, and you see like things like controllers picking up applications and feeding the data into something like this as well, right? I mean,
I think we're looking.
It makes sense, right?
Yeah, I think we're as a PM team, we're looking at opportunities wherever we can to integrate technology and things that we're doing really well on the different platforms and form factors. It's a step-by-step process.
For sure.
For sure. And I mean, we've seen, we thought a lot about how we wanted to approach this. And decided that we didn't want to try to just dive into this big effort of merging code bases together. We've observed what that has been like for other vendors in different categories, right? Not just in SD-WAN, and that's really difficult to do. So we decided to take an incremental approach The first step being adding this automation to build connectivity between the form factors. This is a question of how can we deliver value as quickly as possible. And that was the answer, but that's just the first step.
Sure.
Definitely.
Yeah, I have a bit of a problem understanding what GreenLake is. So in this kind of scenario,
Yeah,
right?
yeah.
In this kind of scenario, let's say I'm running out of capacity, and
Yeah.
And I might want to route some of that traffic up to the public cloud provider, and provision it quickly. Is that where GreenLake fits in? That I can, build that up and add more resources to that side? No, you look perplexed. I must be wrong. How does this fit with GreenLake in terms of provisioning my network?
Yeah.
I think GreenLake's more like the financial model of it, right?
Yeah, it's more of a financial model. It's not actually providing equipment and cloud services. Because that's what I
It's
thought
all of it. It's all of it rolled into one. It's also a single platform, like a single web portal from which you can access all of your HPE apps, if you will. So that could be central, that could be Orchestrator, that could be various other HPE services and platforms that you have that may be cloud and infrastructure related. So that's from a user experience perspective, that is what GreenLake provides. It's a way to access all of them. But then, of course, there's the financial model component to it. So it's a new way of delivering services. Is that
Network as a service, right?
Yeah.
From the Aruba perspective of GreenLake.
right?
But it's not dynamic. It's not suddenly I need it. Can you give me some and I'll pay you? It's not that kind of model.
Not yet. Not yet.
That's what I thought it was.
Yeah.
So my misunderstanding.
Yeah. Yeah.
Thank you.
I think it is like that for certain products.
Oh,
Yes.
Like Synergy or something where you can there's
Yeah.
more storage and compute that you can
Yes.
just turn on.
Okay.
Yeah.
Okay.
Yeah.
Okay. It is. Okay.
But
Yeah.
this where you have a hardware appliance that's doing the encapsulation and that kind of thing, you'd have to get an actual box, right?
Oh, okay.
Yeah. These solutions that we've shown you today in this portfolio that we've shown you today is about about connecting users to the applications that they use to do their jobs every day, and providing security, and doing that in an automated fashion that doesn't make a network administrator or engineer want to bash their head against the wall, that prevents configuration drift from thousands of devices being configured separately, that enables you to, in emergency situation, make one change and block an app, or maybe even a particular role or a user across the entire network with 2 minutes or less of work.